Now today, if you see, approximately as per the data chart of CPCB, you will find 4.12 metric tons of plastic waste is produced. As per this bioplastics, or what we call as compostable plastics, which is readily available in Indian market nowadays, they contribute 0.5% towards the waste, okay, of the total waste. Now, the whole problem idea of sustainability, why this problem happens, what are the challenges what we are facing? The major challenge is that imports, we are importing the material from abroad, that leads to double the cost. So with BCML initiative, maybe within next year or 2 years or the 3 years to come, this cost will also go down and we'll have a sustainable production from sugarcane. And second thing is that, another challenge is that the source segregation which we find in case of the compostable plastics, which doesn't happen. If you go to the compostable or any MRF material recycling facility today, you'll find that they are mingled with the commodity range of plastics. So what happens is that it becomes difficult for the general public to access, to distinguish which is a compostable one, which is a non-plastic one. I mean, the other commodity one. So the right path would be that we need to define which sector which has to go into. If it is a compostable one, now since government has taken a stand in banning 19 product category SUP products, so that's where the compostable plastics can play a major role. Another mechanism which I would like to share is that the standardization mechanism. We have only one specification. There needs to be a product certification as well. We should enter into those kind of sector, like 3D printing, one application is there. Huge market is there in 3D printing. Hygiene application, huge market is there. All the SUPs, those SUPs which are banned.
We all know we have to build circularity one way or the other. Otherwise, as mankind, we're not going to survive in the long term on planet Earth. And I'd like to start with Andy.
Traditionally, we have our systems actually are designed for linear consumption and production, which actually was easy way out in the sense the environmental costs were not internalized when we look at linear economy and disposal. But now, more and more as we look at environmental costs and health costs, circular economy becomes necessary.
Dr. Nayak, what is your point of view?
In India, when we say recycling, we talk of mechanical recycling. We doesn't go to the end of the solutions. So what probably the bioplastic says is you have 4 types of industrial composting is one solution. You also have chemical recycling, you also have physical recycling, and you also have mechanical recycling. So when you go for a beginning of life to end of life, then the circularity is maintained. This is the first thing. And until and unless we have a complete circularity, the materials justification is not there. And at this juncture, probably PLA is the right material to achieve the circularity. PLA waste, which is almost like a virgin material, when it goes to chemical recycling or physical recycling, we must look into those standards, those specifications. We have only 2 standards, ISO 17088, that's the dual standard we had developed long back. Products we do not have. Please try to understand, all the fossil-based product has Indian standard. In bioplastic, we do not have a single BIS standard. Once you have a IS license, your samples are drawn every 2 months, 3 months. You do not fall into trap of contaminants. Today we have contaminants. We are replacing those materials and supporting plastic fraternity in terms of getting into those items which are identified with QR code, product license, and it is easily goes to the circularity.
RNG, how do you see that from your machinery point of view?
From the machinery point of view, PLA has been able to be recycled. We have a couple of customers who are already recycling PLA, and that was something which was a good thing which we could manage. And what I see from the circular point of view is there is a lot of issues with the mixed plastics. things. When it comes to post-consumer waste, the PLA waste as well as the normal polyethylene waste gets mixed up. And at that stage, the issue of recycling increases dramatically. So I think probably some buyback mechanism or a good sorting system would help to do the right recycling from the mechanical point of view.
Dr. Mohanty, you already mentioned some parts, but from your specific CPET point of view, why do we struggle?
The source segregation is still not happening much. So what is happening is that the compostables are also getting mixed with the other plastics, polyolefins or whatever you say. So when it goes to the to the MRF section or something, then people don't understand which one is compostable and which one is the commodity, traditional plastics. So that is how, when it ends up in the landfill, so that is how that is creating problem. That is one of the reasons which is creating problem. So what we should focus is source segregation, proper standardization mechanism, and other thing is that building up composting infrastructure, chemical recycling, which is still in fancy stage in the country, that also needs to come up, and anaerobic digestion as well.
When you design a product, we actually already need to understand how we keep it in the loop and where does it go out in the end. And just staying with you, you worked on a mechanical recycling calculator for the past couple of months. Can you tell us a bit what your findings are and what the challenges were?
The major issue comes when we are talking about flexible plastics. And there are many challenges. One major challenge, as pointed out by many, is segregation part. So collection, of course, it's a low cost part, segregation, and then multiple layers. So that becomes very crucial issue. Also, since it is difficult to segregate, contamination part comes. And that's where my thing comes when you are taking a plastic and plastically recycling it. How many times you can recycle? So consider two cases. One, where you are 100% plastic product, post-consumer product we are recycling. Because of polymer degradation, because of contamination, we can only have only 5% contamination. Anything beyond that, properties degrade drastically. Few polymers can be degraded, recycled 4 to 5 times. Our understanding was recycling, once it comes, it cannot be one system that can fit everything. Mechanical recycling, in addition to other design criteria, as well as at the end, either you have to go chemical recycling or something like which is completely biodegradable or compostable, that will bring on circularity. You cannot just rely on mechanical recycling.
What role will compostable and bio-based plastic play in this from your point in the future?
It will certainly have, even so, because the kind of research activities we undertake, working a lot with tissue culture, working a lot with improving plant varieties, working a lot with agricultural mulching, working with nano fertilizer, looking at bio-based nanomaterials where controlled delivery of fertilizer or pesticides is desired. There, bioplastic has a role to play, because if it the way it is defined, if it can degrade under pressurized conditions, and if it can degrade without actually creating additional problem of microplastics, then certainly bioplastic has a great role to play in not only the work which we do, but otherwise also wherever there is a application of flexible packaging.
If we really want good, clean material, sorting, that is most important, and washing, then good quality recycling. These three are the core.
And to what level do you think can we drive it? Is it possible to get 1%, go to 1% cross contamination? Is this possible?
I have seen people doing up to 20%. That's not a problem. The problem is the shortcut they use during the process. If you avoid the shortcuts and you pass through all the stages that are required for recycling, like sorting, as I said, and washing, proper washing with detergent and then recycling, I think you can achieve at least 20% recyclable
Material
use
content.
without any problems.
That still leaves 80% which we have to solve in the long run, whereas in PLA is a good solution.
I think with time maybe we can increase the quantum, but that is probably if we really implement the right systems in place.
Dr. Mohan, the aspect we are recently coming on to is the aspect of microplastics. Can you say a bit what you're doing there right now and what your thinking is in relation to compostable and non-compostable?
As regards to the compost, what we have been assessing for compostable plastics in particular so far, we have found that they are being able to clear all the heavy metal analysis, the ecotoxicity requirements and other things. So far from our studies, we haven't found any kind of microplastics generation in that.
Then I would like to follow up with a question which I had on my tip of the tongue before. What do you see as the role of the industry and of government?
Industry and government should work together, and of course, like Madam Divya Madam has also shared, it's also responsibility of the citizens to come across to have a amicable, how to discard the end of life. I mean, all the end of life solutions should be in place. We have a lot of end of life solutions. If you see, government has developed EPR portal. In EPR portal, the plastic waste processes, we find end of life solutions are there. How many of them are entering into composting? How many of them are entering into energy? How many of the plastic waste are coming to the cement kilns? So we already have in place. We need to now formalize, we need to now see systematically that whatever end of life options comes in, it goes instead of very high return potential. So consumer awareness, stakeholder workshops and all these things which already CPCB, CPET and our department, we are doing it. We need to provide more on that.
Last but not least, Dr. Naya, you said before already something about standards. I mean, you are one of the driving forces or the author of the SUP legislation in India, which bans these 19 items. What is so difficult to enforce it, and how would you like to change that? What, from your point of view, would be the easiest way to enforce it?
I'll put it this way, we took 8 months, all the stakeholders under Department of Chemical, Petrochemical were called, and with a lot of deliberations, inviting the industries, associations, who identified in the phase 1 19 items. Of course, I was the villain because initially I was the person who was driving. But at the end of the day, all the industry comes to consensus that these are the 19 items should be covered under category of single-use plastics. Now the problem here is that when I say from my first is the contaminants and source segregations, and each of these products, whether it's a film or anything which is coming, so-called replacing single-use plastics, are also not to be used because it has got contaminants or it's a blend of fossil-based and non-fossil based. So these are the challenges. The best answer will be if the products are standardized. BIS has a mandatory to draw the samples once in 3 months, and the samples undergoes testings and it can be known. Point number 1. In India, we have been talking always on mechanical plastics, whether it is a PCR or industry resins, there will be microplastics. But if we really look into the pyrolysis techniques where the purification of the oil in terms of fossil waste and chemical recycling in PLA, then this problem will be completely wiped out. So I personally believe in a country like India, we should encourage mechanical recycling, and we should also take up chemical recycling and physical recycling.
About the recycling mark, right now I think we are using 7 as the number. But are we expecting the new number for specifically identifying?
BIS BCD 12 is working on that, and 7 is very common. Anything is dumped in 7. So we are requesting, please bring one code at least for compostable materials.
True.
PLA, PBAT, anything, then we can go. There are countries where PLA has a number. There are countries which has got PBS as a number. So we can definitely look into that. That will ultimately help to stop littering and segregations and all those things.
The most difficult step on every journey is the first step. And that's what we are here for, to try to make the first step.